Hello everyone, good morning, good afternoon, good evening, depends on when you're watching this lecture. This is going to be the last lecture of the semester. In this I'm going to cover input and output, although you're already familiar with input and output in C. So the two new things that I'm going to cover are the file operation and moving from C to C++. Input output, moving to from C to C++, it's going to be fairly straightforward to understand. Honestly, if you're moving from C to C++, things are going to be slightly easier for you as opposed to getting more difficult. But file operation, I think that's going to be the challenging piece for you to understand. So without further ado, let's get right into it. Okay, so input and output operation, printf, scanf, sprintf, and scanf. The two that you're familiar with already, the printf and the scanf, I'm not going to cover those. We've used it. Printf is for outputting things, right? And then scanf is for input. Now, what is sprintf? It stands for string print. I mean, as you can, kind of guess from the word itself what it's trying to do. This function is similar to printf, but this prints the string into the character array instead of printing it on the console screen. So it's not going to output to the console, but it's going to output to another data structure. Okay, so the format, the way you go about using it is the name sprintf, and the arguments that it takes are the array name, okay, format specifier, and then the variable name. Okay, this is probably destination, this is source, this is the type of format. Let me show you an example of sprintf. This is what you can see right here. So I've got a character array of 50 characters, right? And I've got a equals to 2, b equals to 8, and c and d. So all a, b, c, and d, they're all integer. Okay, so now I do sprintf string, okay, a equals to d, b equals to d, and a and b. So what is a and b? A equals to, that's saying that a and b are integer, and then s is a string. So a equals to 2 and b equals to 2 is now stored into the string, right? That's what I said, right? Oh no, I said it the opposite. The This is the source, this is the destination. Sorry guys. This is the source, this is the destination. It's flipped around. So a and b are going to get stored in string. And then, actually, this is the example I should have started off with. We'll get to the other one next. So 2 and 8 are even number. So when I do printf of string, it's going to have a and b. Why? Because we used sprintf. Scanf. What does that do? Now, string scan f. This function is similar to scanf, but this function reads from the string or character array instead of the console screen. Okay, similar to the fprintf, except this is for reading. That one was for writing. We give it the array name, format specifier, and then the variable name. And now you can guess which one's source, which one's destination. Right? Source, destination, and then what type of format it is. So here, I've got a character string, a string array of 50 characters, and then I've got 4 integers, a, b, c, and d. C and d aren't initialized, whereas a is initialized to 2 and b is initialized to 8. Now when I use sprintf, I'm putting the values of a and b into string. And then I say scanf. The value of a and b is now in c and d. So I use printf and then sprintf and scanf. And then finally what I do is c and d are integer, then I output c and d. Now keep in mind here, c and d weren't initialized. So what is the scanf going to do? Watch. C is equal to 2, D is equal to 8. What it did was string had 2 and 8, right? It put that string into C and D, and then it outputted it. Okay? Okay, so now let's talk about file operations. File input and output, those will be the two primary things that we're gonna focus on. So let's get right into it. Now, why do we actually need files? What happens? So when you're working on a program, once you're done with the program, your input and output is kind of lost. There are scenarios when you're gonna have to save the input somewhere, so another program can read it, or you yourself can read it at a later point. Or if you've got large amount of data to be processed, input or output that can be reused again and again, file operation is going to come in handy. Now, the thing to keep in mind is the maintainability and readability and reusability. Reusability is probably the key thing. If you have data that you're working with and that's going to be reused over and over again, chances are files are the way to go. Okay? What types of files are we talking about? There's two types of files. There's a text file or a binary file. Now, text file, you guys are used to it. .txt, right? It has information in it that you're familiar with. Binary file, it has ones and zeros in it. In C, there is, before I jump into that, the file operation. So text file, text file, right? English text or whatever language text you're working with. Binary file is a little more different because it's got ones and zeros. I don't know if you're going to work with binary files that much, but we'll share an example for you to get yourself familiar with. Okay? And in file operations, there are 4 things you can do with the operation. You can create a file, open a file, close a file, read and write from the file. It's actually 5 things, right? So that should be intuitive. What can you do with the file? Open it, close it, read, write, append, etc. Those are the different flavors you can work with. When you're working with files, you are going to need a pointer to a file. Okay? And opening a file is performed using fopen function. It's defined in the header file for you, stdio.h, that we've been working with. So you don't have to include any other file for files. Okay? And the syntax of opening a file. So you've got this PTR pointer that you declare, and then you say fopen, and you give it the name of the file and the mode. What is the mode? The mode can be different things if you're opening it for reading, writing, appending, etc. Okay? So here, fopen, I'm opening this file, new program.txt that exists already, and I'm opening it for writing. I want to start looking at these acronyms here. So the mode of the file can be these that I'm going to talk about. It can be R. If it's R, that means it's for reading. If it's RB, that means it's reading a binary file. W is for writing. WB is open a file for writing to a binary file. So if it's got the word B in there, that means it's dealing with binary. A is for appending. AB is appending a binary file. R plus, it's for reading and writing. RB plus, it's for reading and writing to a binary file. W plus for both reading and writing. See, you can use either R plus or W plus. But the caveat over there is if file does not exist, fopen returns a null for R plus. If the file exists, the contents are overwritten. If the file doesn't exist, it's going to get created. So depending on your use case, you're going to use W plus or R plus. WB plus for both reading and writing to a binary file. And then if file exists, the contents are overwritten. If not, it's going to create one for you. A plus for both reading and appending. Okay? So you keep the contents of the original file as is, and then you append from the end of it. A B plus for both reading and writing, for both reading and appending to a binary file. Let's jump in into some examples here. So here, this is the first example. I've got a file pointer, and then I'm opening it for reading. So you see that the letter R, and then the program exits if the file pointer is null. Okay, so this is what, if it's null, then you exit. Otherwise, you scanf. What does scanf do? It reads, right? So file scanf is the file pointer scanf from this pointer right here, and you're reading an integer into this num, and then you say value of whatever you read is this. Now the assumption here is file exists, and then you've got integers in it. That's reading. How about writing? So here you're opening a file with W. Okay, W is a keyword for writing. And then if the pointer is null, then you print F error and then you exit out of the program, right? Because you couldn't find the file. It's not going to create one for you, and then you print. You say enter a number, and then you take in that number from the user, and then you use that number that you took from the user, and you output that number into that file, and finally you close it. Now, in the previous example and in this example, you must have noticed we're opening and closing a file, right? Make sure you open and close at the same time, well, in the same program. You don't want to have dangling pointers, or you don't want to open the file and not close it, because you might run into issues. So one program opened it, the other one's trying to open it at a later point. Well, they cannot do that because you haven't closed it. So you've got a pointer pointing to it, but the program is ended. So you don't want to end up in those sorts of situations either. Now let's look at the binary file. So I've got a file pointer right here, and then the binary file have an extension .bin. That's why I'm saying program.bin right here, and then I'm reading a binary file. If it's null, doesn't exist, then I exit. Now what I do, I go from 1 to 5, and I read in this number. Now this number, I have a structure, right? One number at a time, and I read, and then I print to the console, and finally I close the file. Now, this binary file reading and writing isn't very intuitive, because you're using the struct and you have to use size of the structure 3 now, right? And then the structure I have over here has 3 integers in it. Okay, that's why I use size of, and then 1, and then the pointer. You're gonna get used to this working through several examples. If not, it's not the end of the world. I have hardly used binary read and write. So just so you know it exists, play around with it. How about the other way? So you want to write to a binary file. So I've got a structure that can hold in 3 integers. I open the file, WB. It's a binary file that I'm opening for writing. And if it doesn't exist, same thing, it's going to exit out of there. And then I loop from 1 to 5. Okay. And then n1 is equal to n, n2 is 5 times n, n3 is 5 times n plus 1. And then I write. Okay. I write to the file. And then finally I close the file. Okay, so now we're going to jump into the final chapter for the semester, moving from C to C++. I think this is going to be real interesting. This is a fun part. At some point during the semester, I used a C++ example, so I said, forget about the cout, the output statement, minus that, everything is the same. So one thing you should know about C++ that it's built on top of the C. So whatever C has, C++ has it as well. Um, and then it has more. First things first, I want to get us started by um, using the output statement, the hello world. So, I'm gonna run this. I ran it already. Hello world. Now, first thing to keep in mind is in C we had the stdio, standard lib, etc. Whereas in C++ you have the IO stream, which is input output stream. Okay, using namespace std, and then in the main function, if you want to output something, you say hello world, and then end l. End l puts an inline character. That is for output. Now, if you want to input something, let's say int I, um, please enter a integer. I'll explain in a second. Okay, so that was for output. Output is done by using cout statement, and then what I do after that is I declare an integer, int I, and I say please enter an integer. Okay, I ask the user for an input. I've declared int I, and then I do cin. Cin is for taking in the input. Now, different than printf, scanf, etc. The problem with those were you had to tell specifically that look, now this is an integer you're taking in or a character. What type of input are you taking in? C++ abstract those concepts away from you. You don't have to deal with those. You just see in the integer and it's going to work as it is. And then you see out whatever you want, and then C++ is going to know what you're trying to output. So see, I took in the integer and it says integer is 6. The book actually mentions a few other things. Well, okay, there's one more thing that I want to talk about. Is this concept of classes. So C had structures. Okay, in structures you could just have data members in it. All it was is a bunch of data members. Classes are even they go to the next level. So if you look at this class room, it's just public. I'll talk about public in a little bit, but it has three double. It has length, breadth, and height. But classes have this extra um, these another classes have this extra functionality of using functions. I was trying to say how I can explain it to you guys, but they have the ability to give functions to the user. Okay, what do these functions do? They actually perform some sort of arithmetic, in this case on the data member. So if you say calculate area, it's going to say return length times breadth, and calculate volume does length times breadth times height. Okay, so let me show an example here of that class in use. Okay, so here is classroom, three doubles in there, not a problem. And it says calculate area. Area is length times breadth. And then the volume is, like I said, length times breadth times height. But, so I declare a room, okay, similar to a structure. And then I do room 1 dot length, breadth, and height. So I set the individual data member. And then I say room 1, and that's how you access um, a function of that class. Okay? Room 1 dot calculate area, room 1 dot calculate volume. Okay? And those are the results. Now, when it comes to classes and dealing with classes, there are three levels of protection that um, that happen when you're dealing with classes. One is the private members, one is the protected members, and the other one's the public. If if these data members are marked public, anything after public is public, okay? So all these functions are public as well. If a data member or a data function, member or the function of the class is marked public, anybody outside the class can access it. If it's marked private, only the class itself has access to it. And if it's protected, derived classes have access to the protected members only, but not anyone outside besides the derived class. What do I mean by that? If I had this, see, is private within this concept. Length is private here, so it's not going to be able to access it. How about if I make it same thing, protected, it cannot access the member functions or the data members itself. Now, hopefully, and then if it were public, anybody can access it like the way it was. I wish the book didn't really call this interface because um, so it talks about the interface. Interfaces are available in Java, okay? They're available in C Sharp, but they're not available in C++, okay? Um, but the concept of interfaces is there, right? So you can't really say interface and give it a name. Um, but conceptually, interfaces are nothing but a way to describe the behavior of a class without committing to the implementation. Um, so what you're telling the reader or the one who gets the interfaces, these are the methods, this is how the class is going to behave, this is the input and this is the output, without actually having the implementation of those functions. So conceptually, that's what it is. But the keyword interface does not exist in C++. You should not use it. Uh, know the concept, but when we talk about Java or C Sharp, you'll have an actual keyword called interface. In C++, interfaces are also called, well, in what I should say is, I shouldn't say they are also, but I should say they're called pure abstract class. Now, pure abstract class is a unique type of class. In it, you have a pure virtual function and other functions along with it. Um, Now, what is a pure virtual function? A pure virtual function is a function that doesn't have an implementation at all. So by from a code perspective, you'll have the keyword virtual in there, and then data type, which is the return type, the function name, and you'll say equals to 0. The keyword virtual, you might know of it as the reason why you have this keyword virtual is any class that derives from this base class is going to have access to it, and it can extend it, it can add to it, it can change the behavior, whatever. But in this case, the abstract class didn't have any implementation whatsoever, so the derived class are going to implement it. In order, and some of the key things of abstract class you should know is what will make a class abstract. An abstract class is a class that's specifically designed to be used as a base class. That should be quite obvious, right? Because since it has a pure virtual function, you compile it by itself or you try to run it and you try to use it, the compiler is not going to know the implementation of it. The abstract class must have at least one pure virtual function so that uh, this right here equals to 0. Virtual some return type, name of the function, can take in parameters, it cannot take in parameters, it's fine either way, equal to 0. And the same thing for the return type. It can be void without any parameters, but the virtual and equals to 0 ought to be there. And the derived class of an abstract class must implement all the pure virtual functions. Otherwise, it's not going to compile. Okay, so this is a key concept here. We're using abstract class as an interface, although interfaces don't exist, but the concept exists. The concept of abstract class exists. Pure virtual functions, those are useful, those are important, so get used to them. So the rules for the interface, or the concept of interface, declare only pure virtual functions. Okay, so what this slide should say is it's the rules for the abstract data class. It's got only pure virtual function in there, no implementation whatsoever. So all of the methods equal to 0. And you cannot create an instance of an abstract class, right? Because the compiler is not going to know the implementation of the virtual functions. We can create a pointer to the instance of the derived class with a reference of a base abstract class. So pointers can be used, right? But the pointers are really going to be pointing to derived class. Let me walk you through a couple of examples here. So I've got a class CFG, and it's got a public method in there, virtual string return string equal to 0. Okay? This is a pure abstract class right here. Because it fulfills the conditions. The main condition being all the virtual functions equal to 0. In this case, there's only one virtual function, and that's equal to 0. Do we have any other? Let's go through them. Can I create an instance of CFG? No, I cannot because it's a pure abstract class. Then I've got a child class um, that derives from it. It doesn't need the keyword virtual, but it needs the exact signature. Now, instead of equal to 0, you're gonna have you're gonna return something. You're gonna have an actual implementation. So here I've got a child object and a base pointer. So you can have a base pointer point to a derived class. That's what's happening here. Now what you couldn't do is you couldn't say object CFG. So it doesn't know about CFG. The class, oh, GFGs. Why wasn't the object declared? Because it's got a pure virtual function in it. So it doesn't know its implementation. So you cannot have instances of an abstract class. Let's go through another example here. Let's go through another example here. So here I've got um, a class website that's pure virtual, that's abstract. Um, so get a virtual string get name equal to 0, and then I've got a short form class and a full form class that derives both from website. Now, if it's deriving from website, what it has to do is it has to implement get name, get name, get name. And in the driver I've got two objects, right? Short form, full form object one, object two, and then I've got a website pointer. Website is base class. So we got a pointer to base class. First I say, I point that to short form class, and then I call get name. And then I point that to full form class, and then I do the get name. Watch this. What happens? When I do short form, it does GFG. Which is this one right here. When I do full form, I do get name. So that's so when you're using, one thing to keep in mind is when you're using pointers with classes, have the pointer point to the base class first, and then you can have it point to any base class. Food for thought. Try to have it point to the base class, derived class, and then see if you can change it from the derived class to the base class. If it's gonna help or not, but this is just food for thought. The other thing is, the book talks about the header file and the implementation file. What you can do is all of the class header, um, just the names of the function, you can have them in the header file, and the actual implementation of the function in a implementation file, which